Hello. For question number 10, day 10, the first thing we notice there is a graph. And before we read questions to try and before we get confused by the questions, we apply a process that I affectionately call Oyzerga. Oyxirga. O stands for the origin. Is the origin actually 0, 0? And the answer is yes in this case. 0, 0. The y-axis is speed in meters per second. Each increment is 4. The x-axis is time in seconds, and it goes by ones. That's easy. Then we look at the intercepts. There's an intercept there, and there's an intercept there. The next thing is we ask ourselves what we can read, and that is always the axis. So if the question asks about speed or time, we're just going to read it off the graph. The gradient is the slope, which is dividing the axes. And so that is going to be delta V over delta T. Now we should recognize that right away as the acceleration, but we have our formula sheet out with us, and that would draw our attention to this. So we have the acceleration is the slope. And so when we then look at the area, it is multiplying the axes, which is V times T, which is meters per second times seconds, which has units of meters, and therefore the area gives us the displacement. So let's just study the graph in terms of what we can read. All right, so as time increases to the right, the speed increases, and then it stays the same, and then it decreases. The slope, here we have a constant slope that is some number, let's see, delta y is 12, and the delta x is 3, so the acceleration in this case is 4. Up here, there's no slope, so the acceleration is 0, and over here, we go from 12 to 0 over 2 seconds, so the acceleration is minus 6. We look at the area, and we see that the area, as time goes by, increases, and the area keeps getting bigger the whole time. And since the area is positive and keeps getting bigger, that means it is constantly and consistently moving in the positive direction the entire time. Haven't read the question. I've just analyzed what the graph shows, so that answering the questions will be very, very easy. All right, so speed of an object moves along a horizontal straight line. Okay, which of the following for determining the average speed between 0 and 4 seconds? All right, so the question's about speed. So that looks like we're going to read it off. So between 0 and 4 seconds, let's see, we have the speed. It increases, and then it stays the same. Well, what we know in this case is that for the average speed, we have two definitions of the average speed. The first one is it's the total distance over the total time. And the second one is it's the initial plus the final speed over 2. But this one requires the acceleration to be constant. And what we already figured out is it's 4, 0, minus 6. It's not constant, so we can't use this. So we need the total distance over the total time, the total displacement. So total displacement in this case is the area. So that means we have the green area, and we have this pink area that we need to add up. That's the first 4 seconds. Well, finding the area, we've got 3 by 12 is 1/2 base times height. So 3 by 12 is 36. So the area is 18. And over here, we've got 1 by 12, which is 12. So that gives us a total area of 30. And the total time in this case is 4. So we're looking at 7.5 meters per second is the average speed. So we read the vertical axis at 4 seconds. Definitely not. That's only going to give us the instantaneous speed. Read the vertical axis at the average time, which is 2 seconds. Well, that would work if we were only going, if they were consistent. But it's not the case. If we read the time at 1.5 seconds, that would give us the average speed during the first 3 seconds, but it's not helping us with the value of the average speed. Read the vertical axis of the object at time 0. Finishes it. So add these speeds and divide by 2. That's this case. We know it can't possibly be this technique. Divide the area under the graph from 0 to 4. That's the green and the pink. And divide by 4 seconds. That's what we did. And that's why that's the correct method.